Welcome to our tutorial on creating an augmented reality city tour application using Java. Today, we'll take you step by step through the process, showcasing how to combine AR technology with tourism. To make our city tour app, we'll be using a popular AR library called AR Core in combination with Android Studio, which allows us to develop for Android devices. Make sure you have both installed on your computer. Start by creating a new project in Android Studio. Choose Empty Activity for a clean slate. Next, we need to set the required dependencies for AR Core in our project's build.gradle file. Locate the app module and add the following dependencies. Sync your project to download the AR Core library. This library provides the backbone for creating AR experiences by enabling motion tracking, environmental understanding, and light estimation. Now that we have AR Core set up, let's create a basic layout for our activity. Open the XML layout file for your main activity. We're going to use a simple frame layout to hold our AR content. Next, we'll create a class that extends AppCompat activity and check for AR Core support on the device. Add this code to your mainActivity.java file. This code is responsible for checking if AR Core is installed and requesting installation if needed. Make sure to handle cases where AR Core is not supported by the device. Next, we will use the AR fragment class to render AR content in our app. In your main activity, add the AR fragment. In the above code, we first declare an AR fragment variable. Then we initialize it in our onCreate method by referencing the ID of the fragment in our XML layout. Next, let's add some AR content to our scene. We'll display a 3D model when the user taps the screen. First, create a 3D model in a supported format, such as .glb or .gltf, and place it in the Assets folder of your project. Now, create a method to handle screen taps. We will shoot a ray from the camera to where the user has tapped and place our 3D model there. Here we set a listener on the AR fragment that listens for taps on a detected plane. When a tap is detected, we call the method placeObject, which we'll define next. Now let's define the placeObject method. This method will load the 3D model and attach it to the AR scene. In this method, we are using the model renderable builder to load our 3D model from the asset folder and then passing that model to another method to add it to the scene. Finally, we need a helper method to actually add the model to the scene with the anchor. In this code, we create an anchor node based on the anchor received from the hit test. We then create a transformable node to allow the user to interact with and move the model after it has been placed. Ensure to include necessary imports like anchor node and model renderable at the top of your main activity. At this point, you will have a basic working AR application that places 3D models in the real world where the user taps on the screen. Next, we want to enhance our application to integrate city data into our AR experiences. To achieve this, we'll use an external API to gather information about the city we are touring. For this example, let's utilize the OpenWeather API to display weather data of the city where our tour is located. First, register for an API key at OpenWeather. Once you have the key, we can start integrating it into our application. In your project's build.gradle, add retrofit and JSON dependencies for making network requests and parsing JSON responses. Now let's create a retrofit interface to define our API calls specifically for fetching weather data. In this code, we define a method for getting weather data by city name and API key. You'll also need a weather response class to handle the JSON data received from the API. Now, back to the main activity, we will instantiate our retrofit service and make a request to get the weather data. Once we receive the weather data, we simply output the city name and temperature to the log. In a real application, you might want to display this information in a UI element within your AR scene, for example, above your 3D model. Now that we've combined AR and live data for our city tour, we can customize how we present information to users. One option is to create a text overlay in the AR space displaying the weather once a model is placed. This is a simple example representing how to create a text view and overlay it in your AR view. Adjust its position based on the anchor or display mechanism you are using for AR. Of course, there's so much more you could add to this application. You could use a more robust way to display information or support multiple languages for the city tours. You may want to implement location services to fetch the user's current location to automatically show pertinent local information without requiring manual input. Next steps could involve refining the 3D models we use or integrating more detailed data from other APIs like Yelp or Google Places to enhance the information presented in your AR city tours. Before we wrap this up, let's take a quick look at the permissions needed in your Android manifest.xml to allow access to the internet and potentially location services. Finally, let's summarize what we did today. We created an AR application that showcases 3D models in a spatial context, allowing user interactions. We extended this basic functionality to incorporate real-time city data through an API integration, enabling us to fetch and display weather information as part of the user experience. You've seen how important APIs and AR are when creating immersive applications. Thank you for watching. Be sure to experiment with the code provided and think about how you can add your own enhancements. If you like this tutorial, don't forget to like, subscribe, and share. See you in the next video.